Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 788. Please turn to it. 788, and today is our lesson number 98. Let's take a look at it. Very first problem. We are told that x cube equals y raised to 9. And the question simply is, what's the value of x? What is x? Well, let's find out, shall we? But the very first thing we have to understand is that this x cube, of course, can just as easily be written as x inside the parentheses with the cube outside, and then this y raised to 9 can very easily be written as y cube raised to the third power. Y cube raised to the third power. So now we have a quantity here in the parentheses which is raised to a third power. We have a quantity here in the parentheses which is raised to a third power, and we know that if a cubed equals b cubed, then that implies, that must mean that a must equal b. That's the only way the cube of a would equal cube of b is when a equals b. The same exact thing is true here. Since the quantity in this parenthesis cubed is equal to the quantity in the parenthesis on the left hand side or right hand side cube, therefore this implies that x must equal y cubed. That's it. That's all it is. We're done. That was number 11. Let's go on to number 12. Number 12. Let's see what we have there. In number 12, we are given a little picture here. I'm going to reproduce it. Point D, again you have to have the book in front of you. Turn to page 788 and do the problem with me, as I always remind you. Okay, you can't just sit there and stare at the bloody thing. That's not how you're going to solve a math problem. That's not how anybody solves a math problem. You must have the book in front of you and you must actively take part in it. Don't just sit there passively. Point D, as you can see from the book in front of you, is located at 1, 2, 3. 1, 3. This 1, 3. 1, 3. 1, 2, 3. This is our point D. Point C we are given at 1, 2, 3, 3, 1. 1, 2, 3, and then 1. Right here is the point C. Let's connect point C and point D, and they go to origin, and this goes to origin. Voila. So that's our first triangle. Let's take care of this triangle first before we worry about the triangle at the bottom. Let's see what they're looking for. In the xy coordinate system above, which of the following line segment has a slope of -1? So we're looking for a line segment with a slope of -1. Shall we? Let's continue. Well, there are three lines here. We have line OD. But we need not worry about line OD because it's a positively sloped line. OD has positive slope. So it doesn't matter what the slope actually is. It is irrelevant to us as far as we are concerned. We are not interested in it because we're looking for a line with a slope of -1. Because OD has a positive slope, it's a positively sloped line, that is not the answer. We're looking for something with a negative slope. Similarly, OC has positive slope. We're not interested in that either. Let's look at DC, shall we? DC, let's find out the slope of DC, shall we? Slope of DC equals, we look at the change in y and change in x. Going from point D to point C, D has the coordinates of 1 and 3, and this one has the coordinates of 3 and 1. So going from D to C, we're going to start our journey at D and we're going to finish our journey at C. Going from D to C, change in y is 3 minus 1. Change in y is 3 minus 1. and change in x is 1 minus 3. There is your negative slope there. You see 1 minus 3 is going to be a negative quantity. 1 minus 3. Not that we needed that, we can actually see that by visual inspection that it's a negatively sloped line, which is why we're taking our time to figure it out exactly what it is, because had it been a positively sloped line, we wouldn't have bothered with it, just like these two. So 3 minus 1 is 2, and 1 minus 3 is negative 2. 2 over negative 2 has a slope of negative 1. Voila. Line DC has a slope of negative 1. That's the answer. Answer is E. The answer is E. That's it. We're done with it. We're done with it. As far as this problem is concerned, as far as the exam is concerned, we are done with this question. What I'm going to do now is purely for the learning purposes. We're going to actually figure out what's going on with the bottom triangle, even though we already found the answer. But for learning purposes, we'll figure out what's going on with the bottom triangle, alright? So let's do the bottom triangle now. We're done. The answer is E. In the bottom triangle, we have point B, which is located at 1, 2, 3, 3, 1. 3, 1 right here. That's point B. And point A is located at 1 and negative 3. 1 and negative 3. Again, we needn't worry about figuring out the slope of line AB, because line AB, as we can see, is positively sloped, has positive slope. So that couldn't possibly have been the answer. OA and OB are the only possibilities. Let's figure out the slope of OA. A has the coordinates of 1 and negative 3. What is going to be, again, as I said, this is purely for learning purposes. As far as the question is concerned, we are done. The winner is this. This guy is the winner. What was the winner here? These two are positively sloped, must have been DC. The answer is DC. This was the answer. DC has a slope of negative 1. Now do you notice, because the slope is negative 1, well, let's not make it complicated, we're going to figure it out actually. Going from O to A, O has a coordinate of 0, 0, obviously it's the origin. So 0 minus a 3 over 0 minus a 1 is going to give us positive 3 over a negative 1 is going to give us a slope of negative 3. You see, it has a slope of negative 3. It's a very steep line, but it is a negatively sloped line. It doesn't, well, I take it back. We are looking for a negatively sloped line, but it's actually a very steep line. We're looking for a slope of negative 1. We're looking for a line with a slope of 1, which is negatively sloped, which was this guy. As you can clearly see from visual inspection, DC compared to OA, compared to DC, line OA is very steep. It has 3 times the slope. That's not what we're looking for. That's not what we're looking for. What is the other negatively sloped line? This one is a negatively sloped line, O to B. Let's find out. Slope of OB is going to be again, OB has B has the coordinates of 3 and negative 1. So going from 0, 0 to 3 and negative 1, we have 0 minus a 1. 0 minus a 1, which is the change in y, over 0 minus a 3. And that is going to give us this minus and this minus becomes a positive 1 over a negative 3. This one is the slope of negative 1/3. So this is shallower than the line that we found DC. It's not as steep, again, but this doesn't have a slope of negative 1. Obviously it cannot, because you can't have more than one right answer, obviously. So that was it. Let's go on to the next one, number 13. Number 13. In number 13, we are given a log combination, which is a 3-digit log combination. 3-digit log combination. The combination satisfies 3 conditions that are given to us. One condition is that one number has to be odd. One number is odd, alright? One number One number is the multiple of 5. And finally, one number is the day of the month. Is the day of the month of Kyle's birthday. Day of the month of Kyle's birthday is a bloody awkward way of saying that one number has to be a day of a month. Because we do not know where Kyle's birthday is, so it has to be of the month. We don't know which month it is, so we'll see what happens. We're going to start with E. Another thing that we have to keep in mind here, this is a tricky question only because it requires close attention. It's not a difficult question, but it requires, as I said, close attention. Another thing that we need to pay attention here is that if each number satisfies exactly one of the conditions, and they underline, they are very nice to you, they're being very nice to us by underlining the word exactly. A word comes to my mind, a word that I was about to use about a split second ago, but I did not. About a nanosecond ago, instead of underline, I was going to use the word underscore. We'll learn this word in a second. To underscore something means to highlight something, to emphasize something, to accentuate something, to underline something, as I said. Underscore is the word. They're being nice to us because they underscore the word exactly. Each condition has to be used only once. I'm going to read one more time. If each number satisfies exactly one condition. I'm not going to put it on the blackboard. I'm going to leave it up to you to remember that. Each number must satisfy exactly one condition. Let's start with answer choice E. In E we have 34, 30 and 21. Well, let's take a look. We have to have one odd number. In our log combination, we must have one odd number, which we do right here. That does the job. We must also have a number that is a multiple of 5. Between 34 and 30, the one that qualifies as a multiple of 5 is this guy. The last condition that we have is that we have to have one number in our log combination which consists of 3 numbers. The one number in the log combination must qualify as a day of the month. 34 does not do the job because there are no months with 34 days in it. Do you understand? That's all it is. It doesn't do the job. It can be 31 for all we know because we don't know which month it is. Kyle's birthday, they don't tell us which month it is. So it could be up to 31. It cannot be 32 or 33 or 34 because there aren't 34 days in any month. E is not the right answer. Let's look at D. In other words, we could not have said, well, this 21 qualifies as the odd number, 30 qualifies as the multiple of 5, and either one of these two could be the day of Kyle's birthday. No, because each condition must satisfy. I'm going to read one more time the way they say it. I keep saying it the wrong way. Each number must satisfy one condition. Each number must satisfy exactly one condition. Each number must satisfy exactly one number. So we cannot use 21 as the day of the month and as the odd number. We cannot use 30 as a number that is multiple of 5 and the day of the month of Kyle's birthday. We cannot do that. Each number must satisfy only one condition, which means once we used up 30 and once we used up 21, we used up 30 as a multiple of 5, we used up 21 as an odd number, 34 is the only one left, which cannot be a day of the month. Enough said. Number D. We have 20, we have 15, we have 20. Alright. So we have our odd number right here. 15 is an odd number, so that does the job. Do you see the problem here? We have a 20 and a 20. A 20 and a 20 because they are the exact number. Had it been 20 and 25 or 20 and a 5 or 20 and something else, some other multiple of 5 equal to or less than 30 would have been fine. Had this 20 been 30 or had this 20 been 30, it would have been fine. For example, for example, something like this would have done the job, because we can count one of these two numbers as a multiple of 5, and we can count the remaining one as the day of the month when Kyle was born. But they are the same numbers. And each number must satisfy exactly one condition. So it's not going to do the job. They are both multiple of 5, or they are the same numbers. It says Kyle's log combination consists of 3-digit numbers. Combination satisfies 3 conditions. The conditions that we say there, if each number satisfies exactly one condition, which of the following could be the... Oh, actually, this one has a greater problem than I just realized. This is even worse than I realized. I thought the problem here was that there are 2 numbers which satisfy one condition, which is a multiple of 5. But so is this one. There are 3 numbers that are multiples of 5. There are 3 numbers that are multiple of 5. All of these 3 numbers satisfy this condition, second condition, which is a number that's multiple of 5. This is a multiple of 5, this is a multiple of 5, this is a number. Each number must satisfy exactly one condition. It does not do the job. Let's look at C. C says 15, 18 and 16. 15, 18 and 16. Let's take a look. Let's see if this one does the job. Is that right? 15, 15, alright, so 15 can serve as an odd number, alright, so far so good, or rather odd number. Then we need a multiple of 5. Ah, there is a problem, there is a rub. 15, since 15 is the only number that appears in this triplet, which is a multiple of 5 and an odd number, we can either count 15 as the odd number, we can use up this 15 as an odd number, or we can use up this 15 as a multiple of 5, but we cannot use 15 both as an odd number and as a multiple of 5. One more time, each number must satisfy exactly one condition. This cannot serve 2 purposes. So we need an odd number and we need a multiple of 5. We have an odd number, but there is no multiple of 5. If we count this as odd number, then we have no multiple of 5. If we count that as multiple of 5, then we have no odd numbers. This doesn't do the job. Let's look at B. Answer choice B. Oh man, the suspense is killing me. The suspense is just killing me. 14, 25 and 13. 14, 25 and 13. Well, we have our odd number. Again, if we count 25 as the odd number. Oh, actually, why don't we count 13 as the odd number? Why don't we count 13 as the odd number? But then, if we count 13 as the odd number, why not 25? You see again, both 25 and 13, satisfy the condition, satisfy one condition, which is they are both odd. They are both odd. We must have only one odd number in the combination. We must have only one number that qualifies as a multiple of 5, and we must have at least one number that will satisfy as a day of the month. There are 2 numbers here that can serve as odd numbers. They are both 2 numbers. We cannot have each number must satisfy exactly. It should say one condition, not number condition. Exactly one condition. That doesn't do the job. There are 2 numbers here that satisfy the condition of being odd. The answer is A. The answer is A. 14, 20 and 13. See what happens? You see? You see? Here, obviously, there is only one odd number. Odd number is 13. So that satisfies condition number 1. I'm going to put down numbers here. That satisfies the first condition. Then we need a multiple of 5. Second condition, multiple of 5. This can serve as a multiple of 5. And finally, 14 can serve as the day of the month when Kyle was born. That's it. That's how Kyle put his log combinations together. Very easy to remember. He knows that his log combination consists of his day of the birth, an odd number, I don't know how the hell you're going to remember which odd number it was, and finally a multiple of 5, which I also do not know how he's going to go around remembering what that multiple of 5 was. But anyway, this is it. there are three conditions, there are three numbers here in this combination, and each of these numbers satisfies exactly one condition. Exactly one condition. There is no number here that will satisfy two or more conditions. The answer is A. Enough said, let's move on to number 14. Number 14. Sometimes it's just a matter of reading it properly and taking your time. Do you understand? For all values of x greater than 3, the equation above is equivalent to which of the following? Alright, so the equation above that is given to us is this. Square root of x plus 9 equals x minus 3. And since in the answer choices we see no square root sign, none of the answer choices contain a square root sign, so that's your cue that we have to somehow get rid of the square root sign. And how do we get rid of the square root sign? By squaring both sides. We take this side and we square it, we take this side and we square it. And now the square of square root of any number is the number itself, which is x plus 9. And this one, when you open the parentheses, is same as a minus b whole squared, which is a squared minus 2ab plus b squared. So we will get our x squared minus 2 times x times 3 plus 3 squared. I shouldn't take so much time because now if I do it step by step, I can't do it. X squared 2ab is going to be negative 6 and then 9, negative 3 squared. That's all. What can we do then? Oh, I see a 9 here, we see a 9 here, we see a 9 here. If we subtract 9 from both sides, it's going to drop out. I see an x here and I see an x here. Let's subtract. How complicated does it get? Well, I think we're done. That's it, we're done at this point. We don't have to do this thing. So we bring the x down and x equals to x squared minus 6x. That's it. That's how they leave it. So we're going to stop right there. How far you go, obviously, depends on how the question is presented to you. That's it. Now they could have kept on going. This can be written as x squared. You subtract x from both sides and you end up with x squared minus 7x equal to 0. They could have gone as far as this, or they could have gone as far as this. X times x minus 7 is equal to 0. And this would have been the simplest form, the most elegant form, but for some reason they stop right here. And that is answer choice C. Answer choice C says x equals to x squared minus 6x. That's it. We are done with this page. I will see you tomorrow, or we'll continue our journey on the next page, 15 through 18. Alright? Bye now.